Good morning, my YouTube viewers. It's Crystal here. I just wanted to make another video for you. The reason why is because in the middle of the night I was looking at the news on my phone, and there was an article on KD Nuggets about using the built-in statistics model in Python. And so Python has a built-in statistics model. And the thing is that the thing about Python is I have Python installed on my computer, and the reason why I have it installed on my computer is because it's in the Microsoft Store. And because it's in the Microsoft Store, I was able to install it because I don't want to install any software packages that are not in the Microsoft Store. The reason why is if you install a software package that's not in the Microsoft Store, then you lose your virus protection, and I don't want to do that. So I am able to get Python. I think I'm on Python 3.13 or 3.14. And so the statistic model is built into Python. So I'm able to use that. And so basically, what I wanted to do is I wanted to go ahead and use this inbuilt statistics program and check it out, see how it works. Because you've got statistics libraries in Python. So you've got SciPy, that's a scientific library, but it also has statistics in it. And then you have stats models, and stats models is a statistics library as well. And you've got NumPy. NumPy has statistical functions too. So you've got these three libraries associated with Python where you can perform statistical functions. But it's nice to be able to have an inbuilt statistical function in Python. And that's what I'm doing in this particular video. So I'm just going to save what I did. I've saved it. I'm going to save my work. And then so what I'm going to do is I'm going to do the code. And then after I do the code, I'll run it. So we've got two arrays of data. These are sizes or numbers. So you've got size 1 with an array of 11 elements, and then you've got size 2 with an array of 11 elements. And then what I had to do was, because for the linear regression and the covariance, you had to have a second array. So it started out with just the one array, which was size 1. But in order to use covariance in linear regression, I had to put a second array in there, which is size 2. So the mean is your mean of the size 1, and the mean is your average. And so what you do is you sum up all the elements, and then you divide it by the number of elements, and that's going to give you your average. And the median is the center. And so that's different from the mean because it's going to be the center element. And the mode is going to be the most common element. So I think we've got two modes, two elements that are 1200. So I think that's going to be the mode. The mode is the most frequent element. The quantile is they're going to break it up into quantiles. And then the standard deviation is going to be the standard deviation, and the variance is going to be the variance. The covariance size is the covariance, and then you have to use size 1 and size 2 because it takes two arrays of data to work. And one thing that I was really interested in was linear regression. So you can actually perform linear regression on the inbuilt statistics module in Python, which is something that I was really interested in. And then after I have defined all of these variables, then I'm going to print the variables, as you can see. So now what I'm going to do is I've saved my work, and I'm going to run the module. So I've run the module. So we're going to say that the mean size The mean size 1 is 1520. The median size 1 is 1200. The mode size 1 is 1200. The quantile size 1 is 780, 1200, 2500. Standard deviation size 1 is 849.77. Variance size 1 is 722,109. And you need to remember that the standard deviation is the square root of the variance. So if you took the standard deviation, which is 849.77, and you multiplied it by itself, then you would come up with 722,109. That's your variance. Then you've got your covariance of the two arrays of data, which is 673,990. And then you have linear regression, which is what I was really interested in, which is the slope is 0.9333 and the intercept is 10.4714. So those are just a few of the things that you can do with Python's inbuilt statistics library. They had more functions than that, and if you're interested in that, you can look at KD Nuggets article on getting to know the statistics library. But basically, the formulas that I used are the most common formulas, and the formulas in KD Nuggets, some of the formulas are just a variation of the most common formulas. And so that's it. That concludes this video. I just wanted to make a short video just to cover it, just to cover the statistics inbuilt module. So if you've got Python on your computer, then you don't need to install a library. You can just use the statistics model without installing the library, which is what I do. I mean, normally with my Python work, I normally use Google Colab, which allows me to work online, and I don't have to install libraries. But it's really nice to be able to use Python on my computer when I want to. So thank you so much for watching my video. I've covered the important topics of the inbuilt library of statistics. And if you like my video, please like and subscribe. And I look forward to making more videos for you of a technical subject in the very near future.